All right, so today we are taking notes on the last method for solving a quadratic equation, and that's to use the quadratic formula to solve a quadratic equation. So our objective is to solve using the quadratic formula, which I know you already know how to do. Today our focus is refining your process, refining your skill, becoming a master at using the quadratic formula. Okay? So if you could get that down in your notes. Okay, I'm going to answer a question real quick. Divide it off. Okay, here we go. So we're going to start this process by going back to your bell work for today. And we are going to solve the standard form of the equation, of the quadratic equation, by completing the square. But first, I want you to note that in your notes it says write the standard form of the quadratic equation. Okay, that's the first box, the standard form of the quadratic equation. I expect you to know that. This is a test question. So, here we have ax squared plus bx plus c equals 0 is the standard form of a quadratic equation. I expect you to know that. Memorize it, tattoo it on your brain. Okay? This is the quadratic equation's standard form. Okay? Now, that's a test question. Maybe you want to write test question down next to it so you remember to study it when you create your study guide. All right. So we are going to solve this by completing the square, which you started with when we were doing bell work this morning. So what would we do first? We want to move the c first? Okay. So we'll subtract c to put the constant on the other side. So we have ax squared plus bx. Of course, we're going to leave open a space for completing the square, equals c. And I would suggest you write kind of small, because this is a pretty, as you were working through bell work, you found it was a pretty long process, right? A number of steps. Okay, now that we've moved the c to the other side, what should we do? Divide by a. So we're going to divide all our a, b, and c's by a and simplify to x squared plus b over ax equals negative c over a. You'll notice that my x is separate from my b term, which is now b over a. Our next process, of course, is to cut our b term in half. So that would be b over 2a and square it. So let's square b. b squared, square 2, square a. So we are going to add this to both sides to complete the square and maintain balance. Okay. Now we're going to factor the left, our perfect square trinomial, down to x plus b over 2a quantity squared equals. Now over here, you're asked to combine. And these are not like fractions, but we can make them like fractions by using common denominator. Yes? So can I make these the same denominator? Yeah, I can make this a 4a squared by multiplying it by what? So I'm going to multiply numerator and denominator by 4a so that I get negative 4ac plus b squared all over, or both over, 4a squared. Now notice I didn't add those numerators because they're not like terms, so I can't actually add them. But I can make them have the same denominator. Are you ready? Next thing we'll do, now that we've done our factoring and combining like terms, is square root. Right, that's the next step. And we should definitely square root our numerator and denominator separately. And I also feel like I want to really rearrange my numerator so that I don't lead with the negative 4ac. So I'm just going to switch it to b squared minus 4ac. Hopefully you're keeping up with that logic. I don't usually lead with the negative over the square root of 4a squared. Separate because the top's not a perfect square, but the bottom is. And we get x plus b over 2a equals plus or minus. Now I've seen a number of people today, as they're working on this, try to extract perfect squares from that binomial. But you can't, because this is a binomial, yes? Yes? But it's a perfect square. So I can take its square root. This is not a perfect square. It's not. So I can't. So b squared minus 4ac all over, but I can take the square root of 4a squared, which is 2a. This should look really familiar, folks. Yeah? Now all we got to do is move this b over 2a to the other side, push it up front, and we get negative b plus or minus the square root, b squared minus 4ac. And both of them are over 2a. And folks, there we have the quadratic formula derived so that we can solve any quadratic equation we want. Any one we want. Okay. So, that's why completing the square is important. Without it, we would not have this. Okay, moving on to the next box. All right, in the next box, it says to write down the quadratic formula. This is another test question. I expect you to know the answer. And the answer is x equals, P.S. that's important, the opposite of b plus minus the square root of b squared minus 4ac all over 2a. Now I'm telling you right now, if you answer this question on the test and you just write the right side of that equation without the x equals, I'm going to mark it half off. I want the whole equation. Okay? All right. So here's the steps, real quick, for refining our process solving the quadratic formula. Rule number one, step number one is to write in ax squared plus bx plus c equals 0 in standard form. If you want to apply the quadratic formula, the equation has to be in standard form. Also has to be in standard form when you factor, right? But when we complete the square, do we write it in standard form? No, we move the c, right? When we square root property, we also move the c. All right, step two. And this is the refining process. And I know that the freshman teacher teaches this, but I don't know if the sophomore teacher for additional math teaches this. So this could be a refinement for you. I would say that we should divide out the GCF. And the reason I say that is because it can simplify your math. It saves simplification on the last step. Not always, but it'll certainly make it easier. This is an option. You don't have to do it. But it is a refinement step. Step 3, you're going to identify your A, B, and C. Step 4, you're going to plug A, B, and C into the quadratic formula. Notice I'm using my note-taking notations here. Keep up. Simplify. Okay. So that's the process that we go through. And you know the process. This is a review. Remember that your goal is to refine it, to become masterful. Okay? Ready? Here we go. So you have the practice problem that says solve for x when it's 4x squared minus 12x minus 44 equals negative 4. Okay? So let's do it. We'll add 4 to both sides so that we can put it in standard form. Minus 40 equals 0. I have a really strong urge here to factor out the GCF. How about you? Yeah, what is it? So let's divide everything by 4, even the 0. X squared minus 3x minus 10 equals 0. And I got to tell you, I have a really strong urge to factor this, because it'll factor in 2.5 seconds. I could be done with this problem in 5. But we're reviewing quadratic formula. So what's our A? Our B? And our C? Okay, we're not dropping those negatives. We're being careful. And we're going to plug that into the quadratic formula. We're solving for x, so x equals the opposite of negative 3. Notice I'm using parentheses in my substitution so I don't make silly errors. Plus or minus the square root of negative 3 squared. Is it important for me to put parentheses on that negative 3? You betcha. If I put minus an opposite of 3 squared, I'm going to get a negative 9 right there. Can't do that. Minus 4 times 1 times negative 10. See some of you going, I'm getting my calculator. All over 2 times 1. Okay, I don't know what you do, but I tend to work right here before I move on. So this would be 9, right? Plus 40, right? Which is 49. So I tend to just kind of pyramid that up as I go. So I get x is equal to the opposite of negative 3, which is 3, plus or minus 7 over 2. Because that's the square root of 49, which is 7, right? So I get 3 plus 7 over 2 and 3 minus 7 over 2. And again, I kind of pyramid up. I work up. That's 10 over 2, 5. And negative 4 over 2, negative 2. Man, I could have factored that out right there. But that's okay. This year, you're going to learn that you never would have chosen the quadratic formula problem when you could have factored it. Okay? All right, next question. Okay, the next question is when there's no linear term. Here we have the equation 4k squared equals. Now I have a really strong inclination to apply the square root property here and just square root both sides. I don't know about you, but I really do. Can't I just square root both sides? Right? Or I could divide the 4 first and then square root both sides and really simplify my life. But quadratic formula, what are we going to do? Move the 12 over, so negative 12. So we're going to subtract 12. Then we should simplify our lives. Divide by 4. So k squared minus 3 equals 0. Okay, so our A is, participate. Our A is, our B is 0, because we don't have a linear term, which means square root property. Okay, and our C is, all right, so let's plug it in. K equals this time, because we're solving for K, the opposite of 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 3, all over 2 times 1. Got a bunch of nonsense here. We'll simplify this. I believe it should be 12, don't you? So that's the square root of 12. So we get k is equal to plus or minus the square root of 12 over 2. But that's not simplified. Because I can simplify the square root of 12. What's the biggest perfect square in 12? So 4 times 3, square root of 4 is 2. So we really should have k is equal to plus or minus 2 square roots of 3 over 2. And that's still not simplified because we got to do this half of the love. We don't have that half, right? This is 0. So we should simplify all the way down to k is equal to plus or minus the square root of 3 because we can cancel those 2's. So really, really inefficient way to solve this equation when we could have just done this. If you don't mind, I would like to just illustrate why this was a silly thing to do. I could have divided by 4, k squared equals 3, square rooted, plus minus, k equals plus or minus square root of 3. Done. How silly was it to do all of that? Really silly, right? So that's what we're working on, getting there. We're going to get there. We're going to make really good decisions before we take the test. Last problem. We have 9b squared equals 9b plus 2. All right, so what do you want to do? Take the v and the 2 to this side or take the negative 9v to the other side? Go this way? So we're going to say that 9v squared plus 10v plus 2 equals 0. I just put the 0 in the back instead of the front. That doesn't matter, does it? Right? Because I hate to lead with a negative if I don't have to. All right, so should we GCF this? That'll create a fraction. If we were to divide the 9 off, that would just make life miserable. And I'm thinking this is probably not going to factor. So I think quadratic formula, our A is 9, our B is 10, and our C is 2. And of course, I'm not expecting you to write those out if you don't want to, because that's not efficient. This is a note page. So this time we're solving for V, right? So V equals the opposite of 10 plus or minus the square root of 10 squared minus 4 times 9 times 2 all over 2 times 9, which I think I'll simplify up. So that's 100 minus 72. Yeah, negative 36 times 2 is negative 72. So that's 28. Okay, so here we have negative 10 plus or minus the square root of 28, which I'm thinking I'm going to have to simplify, over 18. Looking good, but looking like it can definitely simplify. So let's simplify the square root of 28. What's the biggest perfect square in 28? 4. 4 times 7, square root of 4 is 2. So we'll rewrite that as v is equal to negative 10 plus or minus 2 square roots of 7 over 18. Yeah, I think you're seeing it. I'm thinking I got to show this problem a little bit of love, simplify its life a little bit by pulling out its GCF. So the GCF I heard was 2. So let's divide all those numbers by 2. Negative 5 plus or minus square root of 7. We don't need to put a 1 there. Over 9. Now, we would, of course, separate that into negative 5 minus the square root of 7 over 9. And a positive. Nope, not a positive. Erase. Negative 5 plus the square root of 7 over 9. And there you have it. For the purpose of this problem, the quadratic formula was definitely the most efficient way to solve this equation. It wouldn't have been complete the square, because who wants to divide by 9? And then cut 10/9 in half. Forget that, right? Okay, so there we have it. Those are your notes on quadratic formula. Just a review. Hopefully you're refining your process. You're a little bit better. Gave you 12 problems.